Hello students, how are you? I am Preeti Mahajan. Today we are going to start lesson number 4, measurement of matter. Before we start the lesson, let us recall Dalton's atomic theory. According to this theory, matter is made up of atoms and atoms are indivisible and indestructible. Means you cannot divide them further and they are indestructible also. All atoms of an element are alike. Means if you consider one element, that is carbon, then all atoms of carbon are alike, while different elements have different atoms. For example, if you consider carbon and hydrogen, these are two different elements and obviously their atoms will be different with different mass. Now, important principle of this Dalton's atomic theory is that the molecules of a compound are formed by joining atoms of different elements to each other. Here you can see the diagram. Here water molecule is formed by oxygen and hydrogen atoms combinations. Mean these two atoms combine together, combine chemically to form water molecule. This is called as chemical combination. Do you know the scientists Dalton, Thomson and Rutherford? They studied the structure of substances and the atoms and thus discovered the law of chemical combination. What do you mean by chemical combination? Chemical combination means compounds or molecules are formed when the different atoms or molecules combine chemically to form a new substance. Just now you have learned about the formation of water molecule. It is formed by combining hydrogen and oxygen, that is the chemical combination. And scientists studied this chemical combinations by various laws and they stated the laws of these chemical combinations. First law is law of conservation of matter, which states that in a chemical reaction the total mass of the reactants is same as the total mass of the products formed due to chemical reaction. Now let us understand better with the activity. Now if we in this activity, if we take a sodium chloride, calcium chloride in a conical flask and sodium sulfate in a test tube, and if we weigh them, then this is the reactants mass, because here calcium chloride and sodium sulfate are the reactants, and that mass will be 300.23 grams. Now next part of this activity is if we tilt the conical flask, what happened? That test tube, the solution from the test tube will get mixed with the solution in the conical flask and they will react with each other and product will be formed. That is, product is calcium sulfate. White precipitate of calcium sulfate will be formed in a solution of sodium chloride. And if we weigh them, means if we weigh the product, then product's mass will be again 300.23 grams. Then mass will be the same. Okay, reactant mass and product mass is same, and this is called as conservation of matter. Okay, let's study one more example. Here copper sulfate and sodium hydroxide are the reactants. They will react with each other to form copper hydroxide and sodium sulfate. You can see their weights are also same. Their mass is 60 gram. Reactants product's mass is also 60 gram. Okay, so matter, conservation of matter. Now next law is law of constant proportion. Let us study this law with the examples. Okay, now if we want to prepare a carbon dioxide, 44 grams of carbon dioxide, we need to take carbon and oxygen, 12 grams of carbon and 32 grams of oxygen. Okay, means their weight will be 12 grams and 32 grams only. We can't take whatever we want. Means we can't take 10 grams of carbon or 30 grams of oxygen. No, it should be 12 grams of carbon and 32 grams of oxygen only. And this proportion is fixed, that the proportion by weight of carbon and oxygen is 3:8. Let us consider one more example. Here you can see that if you want to prepare a 9 grams of water, we need to take 1 gram of hydrogen and 8 gram of oxygen. Means their proportion by weight is 1:8 and this proportion is fixed. Okay, so this law of constant proportion is stated by J.L. Proust in 1794, and this law states that the proportion by weight of the constituent elements in the various samples of compounds is fixed. Various samples means just now we have considered the example of water. No matter the water is taken from which source, whether it is taken from pond or rivers, it doesn't matter. In all type of samples, the constituent elements weight will be the same, means it is fixed, that proportion is fixed. Students, as we are studying the about the measurement of water, do you know the substantial contribution of scientist Antoine Lavoisier in the study of matter? Let us know more about his work. He was called as the father of modern chemistry. He had a great contribution in the study of elements such as oxygen, hydrogen, nitrogen, phosphorus, mercury, zinc and sulfur. He also had a great contribution in the nomenclature of oxygen and hydrogen. You know, students, oxygen is needed for burning. Means when substance burns, it combines with the oxygen while burning. And Antoine Lavoisier showed that matter combines with oxygen during combustion. We have learned the law of conservation of matter, right? And to prove this law, we need to measure matter. And Antoine Lavoisier was the first to use accurate weighing techniques to weigh mass of reactants and products in a chemical reaction, and was the first writer of the law of conservation of mass in a chemical reaction. He also discovered that water is made up of hydrogen and oxygen, and also he had assigned systematic names to the compounds. For example, some few examples are given over here: sulfuric acid, copper sulfate, sulfite. Do you know, students, he bagged the honor of being author of first book on modern chemistry, that is Elementary Treatise on Chemistry, in 1789. So students, keep on getting information about different scientists and their important inventions. It will be useful to you. In the next video, we are going to learn about atom, its size, mass and valency. And for that purpose, you need to revise the lesson Inside the Atom of grade 8. Students, revise this lesson. It will help you to understand the next part of this lesson. See you soon. Thank you. Bye.